choice thing.
So what are we doing today?
On the
Lecture is from 9:30 to 11.
I think he's
To
doing that.
10:30?
Has it always been so?
We're going till 12:30. We got a super long.
Full lecture?
Oh, yeah.
Wait, is
Three
it,
whole hours.
is it new content or is it just?
I demonstrate.
Ooh, you should start using the group.
Is it, we haven't done any new concepts since chapter 4.
Yes,
Yes.
a bunch.
Really?
Or-
It's all just.
like it.
I mean, it looks like it, yes, but is it really?
I mean, it's like we build up on it, but still new content.
3 hours of straight lecture.
All right. So last week. Oh, why don't we start out with any questions?
What did y'all do on Thursday? Did we just continue on torque?
No, we were dealing with rotation, with
Crop.
waves.
Waves.
Is that part of the test?
Yeah.
Everything that we did this station
Really?
is part of the test.
It's all fair game.
I mean, I can sit down for now.
You said
Down.
everything on the
Breathe
Rube
in.
Goldberg test,
Breathe out.
that covers everything that will be on the test, right?
Yeah.
Everything.
Does it cover more than what's gonna be on the test?
Possibly.
Okay,
We should actually see what we get done today.
okay.
Did you record the video from Thursday?
I did.
Did you post it on? I couldn't find it on YouTube.
All those lectures.
I'm not sure. I don't remember. I posted some stuff. There was an issue with, there's some stuff recorded in a different class that I did not, that I need to edit out. So, a conversation like this did not need to be put out in the test.
I feel like my
I'm assuming that people don't have personal issues
Okay.
broadcast. Other than me with getting hit by cranes.
Do you feel that actually was beneficial?
No, I don't think this throwing the eraser or the basketball incident really.
I feel like I would love it to teach like that.
But the lesson is, if you're gonna throw something, please hit what you're aiming at. Not the innocent bystanders. All right, so last time we were talking about vibrations and waves. So, why don't we take the two free ends first? And the first harmonic will look like this. And what we're gonna do is try to predict the frequencies that we hear. And again, for those who missed it, two free ends, I got two open ends right here. As I swing this around, it's basically vibrating a particular harmonic. So that will end up being the second harmonic, third, fourth, fifth, briefly. So if this here is the length L, how many waves is this? It's a half a wave. A full wave would look like this, or that's a full wave, this is a half of a wave. So the length, whatever it is half of a wave, or half the wavelength. And so the wavelength is going to be 2 times L. I know that the speed of the wave is equal to the frequency times the wavelength. And the wave we're talking about here is sound waves. Anyone happen to know roughly how fast sound waves travel?
Slower than light.
That is true, I will buy that. It's about 340 meters per second. It is temperature dependent, but we're not really, given the basic room temperature, it's gonna be about that. I think at freezing it's 333 meters per second. So if I measure the length here of the tube, I get a value of L, and the meter sticks there it is. I am going to stretch the tube a little bit, one, to straighten it out, and also as you swing it, it will straighten out some more, but give us a at least somewhat approximate value. So L, 86 centimeters. So I have 0.86 0.86 meters is equal to L, so the wavelength that I see here in the first harmonic is gonna be twice that, 1.72 meters. And I should be able to figure out, calculate the frequency from that. So kind enough to calculate frequency, well, let's see if I can get this to come up. That is on.
Dr. Fox, how did we derive the 340 meters per second?
I gave that to you.
Okay.
There is a formula, but
What is that?
in order to use the formula, we would have to know the temperature of the room and, you know, having done this enough, it's gonna be somewhere around that.
I have a question.
Yes?
What is the
And listen,
units for a wavelength?
it is a length.
Just a length?
Yep, the units of wavelength would be.
Oh.
And then how did we derive the lambda again? Is that the one that we measured with the meter stick?
In the first harmonic with two free ends, a free end you'll have antinodes. So places where the vibrations are swinging the most. You'll have a node in the middle, that's where the vibrations basically are canceling out with each other, and you've got a point with no vibrations. And so if the length, in other words, the length of the tube is 0.86 meters, and that's half of a wave, then lambda is equal to twice the length. That's how I got lambda.
That's what he measured with the spectrometer.
All right, so what is the frequency?
197.67 meters.
197.67
meters.
meters. No, not meters. What are the units of frequency? Hertz. Cycles per second. All right, so what does that sound like? Let's see. So 197.67. Yeah. It's one of these. There we
We can do it again. With that thing.
go. All right, here we go. Yeah. We nailed that. Perfect. Now, the reason what's happening here is I swing this thing around. This end obviously is moving faster than this end. As this end is moving faster, there's a drop in the air pressure up here than down here. And so air basically gets forced up through the tube because this end is swinging more. It's swinging faster. As the air comes through, the ribs basically start vibrating it, and that creates the vibrations, which gives us the harmonics. Unfortunately, in order to get that frequency, I have to be swinging this slowly enough, but too slowly for actually there be enough of an air pressure difference in order to suck the air through it. So you really can't hear the first harmonic. But you can hear the second harmonic. So the next simplest wave, again, just like was said before, is that you add a half wave every time. And so that's the next harmonic. These ends here of the candy wrapper should be the same length, and in the middle should be twice those, as best as I can. So how many waves is this? Yep. So now plugging into our speed formula here. 340 meters per second is equal to the frequency times 0.86 meters. And the frequency is
Three
395.3,
4A.
348 units.
Hertz.
And hertz is capital H, lowercase z. All right, so let's see what that sounds like. 395.340. Crudely, it sounds roughly the same. But let's see if we can actually create the beat frequency. If you recall, if I have two frequencies that are played, that are near each other, that they will sound, you'll get a wah-wah sound. So if I did 395, played them at the same time. If they were farther off, so 395, so let's do 405. You get more of a trill the farther off they are, to the point, at some point, you won't be able to hear the trills. But let's see how close we actually get. Question is, are you hearing a little bit more of a trill that you didn't hear before? I'm glad some of you are. Usually, sometimes I get classes where people aren't hearing it at all. All right, so at least we're somewhat in the ballpark. Let's go to the next one, which is easier at least to produce. So the next simplest, well, you should be able to tell me how many wavelengths it's going to be. Yep. Why? Because you drew it, or did you just add a half?
I just added a half.
Yes. So each one you're going to get a new half. So first harmonic, second harmonic, third harmonic. If I draw it. I assume in your notes it will be drawn better than that. So the wavelength is going to be 2/3 of the length, which is 0.86 meters. So you'll get some number, and I know the frequency is going to be 340 meters per second divided by the wavelength. And the frequency is.
Should be 340 divided by 2.
593.02.
That's why you would do it in your calculator. You could do 340 divided by that, make sure that's in parentheses, or divided by a fraction, same as multiplying by the reciprocal, so that times 3/2 or 1.5, then divide by 0.86. All right, 593. $593.02. Yeah, there's sort of, it diverges more the higher we get. But hopefully you heard just a little bit of a trill there, indicating that at least we're somewhat in the ballpark. That it's what I'm trying to get across to you is not a complete lie. And now the torture of the young people. Yeah. It's just showing off that how young you are. I did stop it, right? Because I can't hear it at all.
Really?
No way.
Oh,
Okay.
yeah, I
That
stopped.
one
thing.
I wasn't really thinking about that, although I should have been, except it was right before class and I was making sure it would work and I had the speakers and I put it up to something like that and then forgot to turn it off, but I couldn't hear it because it was above what I could hear at that point. And it still is. And then at some point early in the class, some student says, "Does anyone else hear this loud ringing noise?" And then, and probably the pettiest thing I've done is some students were outside my office being very loud. And so I just put it up to something like that and cranked it up. Couldn't hear it.
That's like the people that put those ultrasonic things to keep birds and animals off of their lawn.
All right. Back to this, there we go. All right, questions?
So this is 2 free ends, right? This
Pardon?
2 free ends.
2 free ends.
So the one that you used to demonstrate also has 2 free ends?
Oh, yeah, yeah, they're both open. What we'll do next is one free, one fixed, and the fixed end is denoted by the fact that there's gonna be basically water at one end and air at the other end.
How would that look like when you draw it?
We will get to that.
This is the first, second, and third harmonic, right?
Yes,
Which was the one that skipped even?
the next one.
Oh, okay.
All right, so for this one, and I'm hoping it's not gonna leak. Hopefully, I'm not going to. Oh. If you're sensitive to really high-pitched noises. Oh, good enough there. Yeah, I should have had only one on it. All right, so what I'm gonna do is I'm gonna fill the tube. And so a little bit of extra knowledge is that as I pour water into, I could pour water straight into here, or I could pour water into the reservoir.
It's somewhat leaking.
It is somewhat leaking. Oh, and down there, we have.
Yeah.
All right, so water is moving up here as it's moving down there, and they will basically equilibrate at the same level. I don't think it's shooting out anymore, at least.
Oh, is it?
Oh.
It's leaking. Oh.
Oh, wow.
Oh,
The
it's-
carpet.
Oh, wait.
The carpet.
Oh,
No.
What?
Sitting in the bottom as well.
Well, yeah, it was, I have to stand here now?
Oh my God, I carried it. Yeah, let us know how it works. Demonstrate. You're on camera.
Well, you see,
Oh, you are on camera.
yeah, I just thought about it.
YouTube famous right here. It was
Apparently
leaking
we're gonna have
so
some
much.
crappy duct tape.
It's like a new top.
What's that?
It's like a new top.
Bravo.
Thank you. Perfect.
Yeah, kind of pee all over the floor.
Well, at least it's not peeing on me and I have to go, no, it was an experiment that went on.
It's leaking.
Oh, yes.
It's
Not
over here.
again. It's got a little hole. They usually do it too. This is like my car and all.
I just wanted you to feel like
Oh,
we're
it's
with
still-
you.
Is it still leaking on top?
All right. Most of it goes in the jar.
And do you ever leak out? Did not grab one of the ones that was in the sink, figuring that those were the ones that leak.
Yeah, what is